Alright, so in this clip we're going to be going over how to evaluate definite integrals. Alright, so to get us started we're going to take a look at the formula for definite integration. So let's start by defining what the integral of f of x is. Okay, so let f of x plus c be the integral of f of x, then the integral from a to b of f of x dx is basically the antiderivative f of x evaluated at the upper limit minus the antiderivative f of x evaluated at the lower limit. This, ladies and gentlemen, is known as the fundamental theorem of calculus part 1. Alright, so someone might wonder where is the c component for the definite integrals. The c component is absent because whenever you're computing the definite integral, you're going to have a plus c part and a minus c part. The plus c part comes from f of b and the minus c comes from f of a, and these two parts take each other out. So you have a cancellation of the constants. That's why you do not have any c's for the definite integral. Okay? Alright, so now that we have the formula, let's go ahead and take a look at some examples. So the task here is to evaluate the definite integral. So evaluate the definite integral. Alright, so the first example, number 1, let's say you want to evaluate the definite integral from -4 to 0 of 2x plus 1 dx. Now, how do you know that this is a definite integral? It's definite because you have upper and lower limits of integration. These are called the limits of integration. Okay? So what we're going to do is we're going to use our integration rules to find the antiderivative of this linear binomial, and then we're going to evaluate it at the top minus its evaluation at the bottom. So what you want to remember is the rule for integrating terms of a polynomial. So recall this is the power rule for integration. The indefinite integral of x to the n dx is, so this integral is going to be x to the n plus 1 over n plus 1 plus c. Okay, something to keep in mind. And also for constants, if you're integrating a constant, let's say constant a, the integral is simply going to be ax plus c. Okay? Alright, so with these rules in mind, let's go ahead and proceed with integrating this expression. We're going to carry out term by term integration. So when you integrate 2x using the power rule, you're going to have is 2x to the first power. So let's rewrite the problem. Integral from -4 to 0 of 2x plus 1 dx. So this is going to become, factor out the 2, and then when you integrate x, you have x to the 1 plus 1 divided by 1 plus 1. Okay, you have power plus 1 divided by power plus 1. That's for the 2x component. And then we're going to use a constant rule for 1. This is a constant, so you just throw in an x behind the 1, so it's just 1x. Okay. Now, we have limits of integration. What you do is you place the limits to the right side after integration. -4 and 0. Okay, so here we do not have the c's because they will cancel each other out, as is always the case with definite integrals. So let's go ahead and simplify the quantity in the parentheses. We have 2x to the second power over 2 plus x, evaluated at 0 minus what you get when you evaluate it at 4. And then we can simplify further. The 2's divide out. So we have x squared plus x, evaluated from -4 to 0. Okay, so what we're going to do is we're going to plug in the top limit into both variables, and then we're going to subtract that from what we get when we plug in the lower limit into the variables. Okay? So basically the antiderivative evaluated at the top minus the antiderivative evaluated at the bottom. So we're going to have x squared becomes 0 squared plus 0. This is what you get when you evaluate the antiderivative at the upper limit minus the antiderivative evaluated at the lower limit, which is -4 squared plus -4. Because of the negative operation here, always put the antiderivative evaluated at the lower limit in parentheses so you don't make mistakes with signs. Okay? 0 squared plus 0 is just 0, so we have minus. -4 squared is positive 16. Positive 16 minus 4 is going to be the opposite of 16 minus 4 is 12, and that's your final answer. Let's try another example for problem 2. What if we want to evaluate the indefinite integral from -5 to -2 of x plus 1 dx? Okay, so what we're going to do first is we will find the antiderivative of x plus 1, this linear polynomial here, and then we'll evaluate it at the upper limit minus its evaluation at the lower limit. So when we integrate x, this is x to the first power, that's going to be x to the 1 plus 1 over 1 plus 1. And then when you integrate 1 using the constant rule, you're just going to get 1x. So this is 1 plus 1, and here is 1x. Okay? So this will be evaluated from the lower limit all the way up to the upper limits. Let's go ahead and simplify. If we simplify, we're going to have x squared over 2 plus x evaluated at the lower limit minus that evaluated at the upper limit. And then we're going to go ahead and substitute. So we have, we plug in the upper, -2 squared over 2 plus -2. That's the entire thing evaluated at the upper limit minus the entire thing evaluated at the lower limit, -5 squared over 2 plus -5, like that. Now, using our order of operations, we're going to simplify these two quantities here. -2 squared is 4, so we have 4 over 2 minus 2. This minus, here we have 25 over 2 minus 5. Don't forget your parentheses because you have a minus operation there. Now, since we have 2 as a denominator here, we might as well express everything using 2 as a denominator, and then we can just combine all the fractions. So this becomes 4 over 2. If you express 2 as an equivalent fraction with a denominator of 2, put it over 1 and times it by 2 top and bottom, you will get 4 over 2. So you have 4 over 2 minus, over here, 25 over 2, 5 over 1, times it by 2, top and bottom. And then this sign is distributed to 25 over 2 and 5 over 1, which can be written as 10 over 2. Okay? 4 over 2 minus 4 over 2 are opposites. They take each other out. Negative 25 plus 10 is negative 15 over 2. And that's your final answer.